Thank you for the introduction. My name is Atsumasa from Waseda University and Osaka Metropolitan University in Japan. I will talk about the effect of the parasol on the physiological response of human body by subject experiment. And parasol is portable and easy to place in the individuals. But the temperature rise of the shield due to the solar radiation absorption, and this is the reflection from the ground. And then we investigate to the effect of the sunshade of the human body through subject experiment and numerical analysis. And firstly, to the subject experiment, experimental protocols, and three stages. The first stage is building shade standing, and the second stage is the four pattern, the sun area and the standing, and the parasol the standing, and the sun area and the walking, and the parasol and the walking. And the last stage is cooling down stage is the maybe each the 10 minute to the 24 minutes, and then the before the outdoor experiment to the 60 minutes in the indoor rest, and whole body is shielded by the parasol, and the walking is a treadmill, and this is subject is all male the student, and number of the subject is 40. Then the parasol characteristic to the about the 1 meter, and the color is this is beige, and the back is black, and this is solar radiation from the 6 point, but the back here is no absorptions, and the infrared emissivity is the same. Outer and the inner side is almost the same. And then the measurement items environment factors, air temperature, relative humidity, solar and infrared radiation, whereas wind speed and the temperature, global temperatures. And the physiological factors, skin temperature is 7 points, and body core temperature, and we use Richter temperatures. And the weight is to the use to the sweat rate, and in this measurement space. And the blood flow, and the heart rate, beat rate, and the metabolic rate, and the blood pressures. And psychological factors, thermal, carbon, and fatigue, three factors. And then in actual the environmental conditions. And this is a wide range, a large and impact to the evaluation to the maybe 28 degree to the 38 degrees C. And the subject experiment date is sunny days, and maybe the global solar radiation is the same values, and relative humidity and wind speed. And then from now, the measured result and the effect of the solar radiation shielded by the parasols. And the three areas, the sun area, and under the parasol, and the building shade. And this is the absorbed the radiation fluxes. And this values is measured by this is simulated human bodies on this size. And then this case, three cases, mean radiant temperatures is about sun area is 6 degrees C, and parasol is 45, and maybe the building shade is lowest values of the citrus, less than the 37 degrees C. And this line, that line is the infrared radiation flux from the human bodies. And this is over the above the red line, dotted line means net radiations. This area net radiations. And the result is 62% reduction in the net radiations and the parasol and sun areas. And this is in this case is 47% reduction in absorption solar radiations. And these two cases and more infrared radiation under the parasol and than in the building shade, and caused by the temperature rise of the parasol. Then this case is a core temperature rise to the second stages, and the standing position and the walking cases, and the sun area and under the parasol the area. And this standing position is the effect of the core temperature rise to the decreases under the parasols compared to the sun area. But the working cases was not observed in the but the effect of the parasol was not in the standing position, standing position, but not in the walking position. And the temperature rise was walking due to the walking, maybe due to the muscle metabolism, the walking cases dominating. And because core temperature measures is in this case is rectal the part, and this case the reasons is many. And then the perspiration and the standing position and the walking case, and the perspiration, and this is a decrease in the body water content. The perspiration decreases both core temperature and the skin temperature decreases. And the two cases is effective, significant effect to the perspiration that decreases in the parasol areas. And there is no significant difference in the rectal core temperature and the skin temperature, but there was a difference in the perspiration in the walking cases. And there is a possibility that this is a difference in the head core temperature, and this is a possibility. Then I will try to the analysis of using the human body thermal models. And this model is a JOS3 model, and this model is 17 body parts. And each layer, each part is 4 layers, and to the transport the blood flow. And then this is the radiation temperature, and the standing and walking on the physiological activity ratio changes. And then this is the core temperatures, pelvis, and this is head, and this is the difference is that in this case is 0.117 degrees C in the core temperature of head. And it is suggested that this is a cause of the difference in the perspiration in the experiment under the working conditions. And then cover only the upper body cases. And in the experiments, the whole body was put on the shade of the parasol. And this case, in the analysis, is upper body parts shielded, and the lower body was exposed to direct solar radiation. And this is the conditions. And then this case, the perspiration and the mean skin temperature change and the core temperatures. And the three cases, even if the lower body is irradiated with the solar radiation, and the increase in the perspiration, skin temperature, and the core temperatures is small. Even with the shielding, with only the upper body, and the shielding effect is close to the physiological response, whole body. And this is the whole body, and the upper body shielding not so change, the small changes, and maybe the very okay. And then the conclusion: the from this outdoor environment measurement, it is confirmed that the radiation load was reduced to the shielding the direct solar radiation from the parasol. And the experiment of the subject showed the use of parasol had the effect of the physiological responses, and the reduction of the heat flow was found to the effect of the perspiration or temperatures in temperature, heart rate, and summer sensations. And this is the difference in the core temperature of the head was confirmed. It was concluded that was caused the difference in the perspiration subjective effect. And the analysis of the human body, summer bonded, the confirmed the shield X. Only the upper body was sufficient to reduce the summer. Thank you very much for your attention.
And someone has a question?
So how much infrared emission did you get from top of the bottom of the parasol onto the person? Do you think that's a substantial one? Do you know how hot the parasol got?
Yes, a parasol is maybe about 1.7 meter, maybe the top of the parasol.
Do you know how hot it got the parasol?
The temperature.
The temperature.
Temperature is maybe this case is 40 for the less than the 50 temperatures. And this parasol is reflected the solar radiation is 60 over the 60%, and not so absorbed, and maybe not so the temperature increase is not so large, but maybe over 40 and maybe less than 50 degrees.
Thank you for your presentation. My question is about calibration setting of the JOF3. So you present the not very much difference between whole body irradiance and upper body irradiance case. Yes, and my question is, how do you calculate the shape factor of the irradiance? You measure the radiation of the global solar radiation.
This case is the ratio of the receiving of direct solar radiation is hand, and this case and other the lower the leg and the foot on the all the exposures to solar radiation.
Okay, and how do you set this parameter? How do you set this number? You configure the solar altitude or direction of the azimuth of the solar.
This case is the in the midsummer in some case. In some cases, maybe in Japan is it almost the perpendicular. Yeah.